In today's lab, we will actually take advantage of chemical and physical changes and put them to use. Okay? So in our physical changes, the chemical composition of the substance remains constant, like the melting of ice or boiling of water. And in a chemical change, the chemical composition of the substance changes, a chemical reaction occurs. Okay, so what we're looking at in our upper right-hand GIF is that we have the triple point for cyclohexane. It stays, or it has all three phases, but it still stays the same compound. Okay, so the physical property doesn't really change, okay, or it's easily reversible. In a chemical change, we again change the different substances. Our little GIF man again explodes into little pieces, and those little pieces do not represent our GIF man from the beginning. Okay, so in the first part, we're going to take a look at density. Okay, density is really a conversion factor that relates to physical properties. Mass and volume. The mass is typically represented in grams and the volume in milliliters. Okay, and it depends on the substance. Sometimes we don't want to do milliliters, but for today's lab, milliliters makes the most sense. When we measure our mass, that's used measuring or using a balance. So again, we want to report all of the significant figures that come out of the balance. When we go through and look at volume, we'll use a graduated cylinder. With the graduated cylinders, we do want to be careful if you're using a glass one to protect the bottom of the glass with a little rubber stopper, so that when you drop the metal in, potentially, maybe, you don't break the glass. Okay? If you use a plastic one, you don't need that little rubber stopper. So if we can measure our mass and volume, we then just do this calculation. Mass value divided by volume value, and we'd be done. We'd have our density. Okay? Except when we look at measuring mass, that's typically with a solid. When we look at measuring volume, that's usually used using a graduated cylinder with a liquid. How do we measure a solid as both a mass and a volume? Well, we could bust out our awesome geometry and trigonometry skills. If we had a square, we could say length times width times height and get that all figured out. Okay. Or what we could do is take advantage of Archimedes. Archimedes went through and said that when we measure our volume, the object, when dropped into it, will have to displace an equal volume. The volume of that displacement must equal the volume of the container. Okay? And I can indirectly measure the volume of my object without having to do any fancy, really fancy calculations. I do have to do subtraction. Okay? And I can get the volume. Pretty cool. Okay? For this part, you are asked to come up with a procedure. We've kind of just talked about it. We need to figure out the mass, we need to figure out the volume. Write out the individual cookbook steps on how to do that. Okay? That's what you're trying to go through and do with that part of the procedure, okay, or that part of the lab. Okay? And then you will use that information to identify the metal that you're working with. However, big issue pops up. These tools have different precision. Okay? When operating on each other mathematically, what happens to the significant digits? Ouch. Sig figs come back to haunt us and could potentially mess with all of our calculations. Okay? So when trying to identify our metals, okay, we could use density. Okay? But if I gave you a giant block of some really heavy, kind of yellowy, let's say goldish looking metal, would you go through to measure the density, or would you just steal it and leave the lab and retire? Okay? You might just run off with it. Why? Why would you run off with it without calculating the density to figure out what it was? Okay? You're already making a guess as to what it is based on the physical observation. Okay? You have eyes. Use them in this lab. Okay? Take advantage of what you see and allow that with the density measurement to help you identify the metal. Don't do it with just the density alone. The next part is all about chemical properties and ultimately figuring out white powders. Okay? So in this part, you will rely on the chemical differences between several unknown white powders. Uh-oh, Unknown? That sounds like a quiz question. Careful observation of both the starting physical and mixed chemical interactions will help you identify the unknowns. Okay? You have to have both the physical and the chemical interactions. If you don't, you will have a hard time finalizing this lab. So be very careful with those observations. Okay? This experiment is also flawed if you do not know what the known reactions are. Okay? So if we gave you a thing of salt, how would you know it's salt? Remember, you can't taste. Hopefully you heard that already in a safety thing. Don't taste stuff. How would you know it's salt? Okay? You would know it's salt based off of your interactions with salt in the past. If you don't have that yet, we need to know what those known reactions are. So maybe looking up what these chemicals are ahead of time could help you out. Or maybe you should do a very careful and thorough reading of the background information, because maybe it'll give you some information to start off with. And with that, we have what is potentially the shortest video, I believe. Let's check. Fantastic. Thank you, and good night.